Hello, my name is Christy Harris, and I'm the Director of Technology and Privacy Research with the Future of Privacy Forum. I've been leading FPF's Location and Ad Practices Working Group for a little over a year now, having spent about 20 years in the online services industry, focused on advertising and various products and services. I'm joined today by Rob Van Eyck, who is FPF's European Managing Director. And Rob, would you like to take a moment to introduce yourself?
Yeah, good morning, Christy, and hello to all the participants. I hope you and your families are as well as can be during these challenging times. I think we have a really interesting presentation for you today, and give it back to you now for the host. Go ahead, Christy.
Thank you. On behalf of both Rob and I'd like to welcome you all to today's webinar on understanding online advertising. Before we begin, I'd like to mention a few housekeeping notes. This webinar is being recorded and may be shared for later viewing. The webinar does include slides and valuable visual content, and for the best experience, we highly recommend you join via the video link provided in the registration confirmation. For your privacy, all participants are joined with video disabled and in listen-only mode, muted by default. However, we do hope you'll join the conversation and ask any questions you may have as we go. At the bottom of your Zoom window, you should see a link to Q&A, which will allow you to ask questions in real time. Charlotte Kress, FPF's Adtech Fellow, will be monitoring this window and will ensure your questions are raised and addressed. You may also use the chat function to communicate with other attendees as well as sort of a back channel. My goal in today's webinar is to provide you with a basic online overview of the advertising ecosystem and familiarize you with the terminology you have likely heard but may not have understood or wanted to ask about. While there is significant debate over the privacy and policy aspects of online advertising, today I'll leave that to the policymakers and instead focus on giving you the fundamental language and understanding necessary to work with your teams internally, as well as external communities influencing these discussions. Rob will provide you with a far more in-depth look at various related subjects, including the various browsers and how they work, real-time bidding or RTB, the demise of third-party cookies, and some of the ongoing discussions regarding solutions under development to replace them. And with that, I'm going to jump into the basics of ad tech. What is ad tech? Well, advertising, we all know what that is. And the emerging technologies, starting back in the 1990s with internet and video smartphones and all of the apps and connected devices we see today, the two of those come together and bring us what we call ad tech. Advertising has been around for an eternity, from old print ads to online media. And this medium actually is a incredibly fast growing and incredibly high dollar medium. So it is very important to the economy. And I think it's important for us to understand the fundamentals of how it works in order to craft the policies around it. So basically we have two different sides to the conversation. We have the advertisers on the left, which are the buyers, and the publishers on the right, which we refer to as the sellers. The advertisers have creatives or ads that they want to sell or messaging that they want to get in front of a specific audience to increase brand awareness, to reach certain demographics, or to reach their existing customers. And the publishers or the sellers have access to those audiences. They have the space or the inventory to publish the ads. And by doing so, they're able to defray the cost of publication by giving content to their users for little or no cost. It helps them to also analyze their content for improvement. And the obvious quote that we hear all the time in this context is that from John Wanamaker, that half the money I spend on advertising is wasted. The trouble is we just don't know which half. So back in 1994, AT&T placed the first ever banner advertisement with all the beautiful colors that we have come to expect from online banner advertising. It was placed on hotwired.com, which is not the current hotwire.com that you would expect, but it was a beautiful ad that was static. It was sent as a file that was embedded, hard-coded into the site, quite different from how we see ads these days. So the basics of a website. When a user goes to a website, they type in the URL or the web address. In this instance, we're going to use newyorktimes.com as an example. And that browser or the client side then makes a connection to the New York Times server, which is the server side. It will also send an HTTP request, which includes a variety of information that tells the server the type of browser, this operating system that's being used, the size of the screen, various different data elements that are necessary for the server to be able to respond. This will also include cookies that might belong to that actual website. The website then returns a set of instructions to the browser, and that may also include the integration of third-party content such as fonts, images, analytics, plugins, social plugins, videos, and so forth. Now, it's important to note that the context of first and third party is very distinct in a browser context from what you might expect in a legal context. Browsers take this terminology very literally. First party is the actual website that is providing, or that has actually been contacted. So in this instance, it would be the newyorktimes.com. And anything that is not newyorktimes.com is considered a third party. But third parties are necessary to provide various different elements to the website. So when you see it, there are different components. When you actually view the website, there are different components that may be provided either directly by the first party or by third parties. And that could include advertisements, analytics, other features like commenting and social media or videos. There's also a mention here of tags, which are 1x1 pixels. They could also be 0x0 pixels. And we'll get more into those in just a little bit. So what are cookies? Cookies are basically a text file that can be stored by a website in a browser on your computer. They were created many, many years ago to offer a mechanism for state management. So in the early days of the internet, a user would go to a website and it would look the same for every user who went there. There was no difference from one user experience to another. So when a user logged in and they started to navigate from one site to another, there needed to be a mechanism that allowed, or when they navigated throughout a website as an authenticated user, there needed to be a mechanism to maintain state, to maintain a shopping cart, or to recognize that user and be able to provide them with an experience that is specific to what they would expect. And cookies were that solution. Jumping back, it allows users to have, for example, a shopping cart, or to remember a login, or also to remember other preferences so that when they return, they can have a more customized experience. So the setting and reading cookies. When you go to newyorktimes.com, on your very first visit, you won't have a cookie. So the server sends back instructions to save a cookie. And that information typically includes a unique ID and can be used later to reference that same user. So on the second visit, when the user comes to the site, the browser cookie is sent back to the server. The server recognizes it as the same person it saw the first time and can then return personalized content. So for example, if you have weather and a zip code has been provided on a first visit, the second visit would allow the site to then provide you your local weather without having to reprompt you for your zip code or other information. I've given an example of what the browser sees as a cookie on this slide. So if you actually look in your browser, you can see the type of information that's provided. The value on the far right is the actual content that is stored within a cookie. And you'll see that an actual cookie is not necessarily problematic on its own. It is merely the mechanism for storing text. And it is up to the actual websites as to what they store in it. So it becomes a more controversial discussion when looking at the actual information that sites decide to store in a cookie. So I mentioned pixels and web bugs or tags as a 1x1 pixel or a 0x0 pixel. These are placed by the website owner. So New York Times can put a pixel on their website that is either incredibly tiny and virtually impossible to see, or if it's a 0 by 0, it is invisible to the naked eye. It basically is a piece of code that puts an image on the screen that makes a third-party request to another website. So for example, if you are on, say, a Nike website and there's a picture, or you've gone to a Nike website, now you go to the New York Times, the pixel on the web page could call back and say, ooh, this is the same user that we saw elsewhere, and be able to provide analytics. It can provide different measurements. It can help with targeting of advertising and the tracking of users across the internet for customized experiences. So we do a throwback to the early days of online advertising. Back in 1994, the original advertisement that was placed on the Hotwired website was a direct relationship between an advertiser and a website. And that is how many of the early online advertisements were configured. Each advertiser had a deal with individual websites. And as you can see, this gets incredibly complicated. As more advertisers come online and more websites are available, it becomes a very difficult task to manage all of them. So ad networks begin to appear, and they help to streamline this process by allowing multiple advertisers to work with one company who then works with multiple websites. You may have heard some of the names: Ad.com, DoubleClick, Dakota, Right Media. These are some of the early ad networks that you may have heard of. They also helped to provide better reporting for advertisers across multiple websites, and they allowed for competition for smaller publishers who may not have had relationships with some of the bigger advertisers. But even this became inefficient as the ecosystem evolved. So around 2005, we see the introduction of ad exchanges, which helped to automate the buying and selling of ad inventory. And then as that ecosystem becomes complicated, we see the introduction of DSPs, which is the display side platforms, and the SSPs, which are the supply side platforms. So it's a supply side platform, or an SSP, enables publishers to auction their ad inventory to a variety of buyers and advertisers. And they specialize in matching advertisers with various publisher networks in an automated manner. You may have heard of some of the SSPs like AppNexus, which is now known as Xandr, PubMatic, and the Rubicon Project. A demand side platform, or a DSP, is on the advertising side, and it allows various advertisers to bid for the available ad slots. They specialize in running advertising campaigns on different websites that are targeted to the intended audience at the right time. And advertisers can then bid on various criteria such as location, gender, browsing history, or other information that they may have stored in cookies about individual users. And examples of DSPs that you may have heard of: AppNexus, AdForm, DataZoo. Facebook has a DSP, MediaMath, TubeMogul. There's a wide variety of both SSPs and DSPs out in the marketplace. And I'll give the caveat now that much of what I'm explaining is the very basic fundamentals. This is a very complex ecosystem, and there are always going to be alternative solutions and different implementations offered by various companies to solve different needs for various clients. So these are examples of DSPs that are available and SSPs. But if you look at the ad tech value chain, this is a very highly simplified visual of how the ecosystem works. On the left side, we have your users that go to the different publisher sites. On the right, we have advertisers who work with agencies, trading desks, and their campaigns are fed into the demand side platforms for the bidding services. And then on the consumer side, we have the ad networks and the ad servers that make up the supply side platforms and run the auction services, and the two come together. Outside of this partnership, there are also various different brokers and other service providers that provide different data management platforms and different functionalities to both the advertisers and in the role of targeting of advertisings and optimization. So when you hear the term programmatic, what is programmatic? Well, basically, it's just the automation of the online advertising. Advertising is often targeted based on a number of different types of mechanisms. You'll hear the terms contextual, which is advertising that is targeted based on the content of a website or the nature of a website. So for example, if you are going to a news article about, or a news section about travel, you might see ads for luggage or airfare, hotels, car rentals, maybe insurance related to travel. That is related to the content of the site and is usually not considered, does not consider the actual user that is visiting the page. You may also see retargeted ads, and those are ads that are served to a user based on a specific behavior they exhibited previously with an advertiser. So in my example where I had visited the Nike website earlier, and then I go to New York Times, I may see an ad for the shoes that I was looking at because Nike is trying to reach the customers who have previously been on their page. And that is a retargeted ad. It's done typically with a tag, and it allows advertisers to reach their own customers. Behavioral advertising, also known as interest-based advertising or tailored advertising, depending on the context of where you're hearing it, is advertising that is based on some sort of previous behavior the users have exhibited or profiles created about a user. So you'll hear the terms audience segment, which might be users who are known to be auto intenders, somebody that we believe may be interested in purchasing a car because they may have been looking at auto websites, or an auto manufacturer may know that a lease is coming up and that that user may be looking to purchase another vehicle and wants to target their ads to that user. So using offline data, they are able to then find a mechanism to serve ads based on consumer behaviors. You'll also see various different pricing models for the serving of advertising. You'll hear CPC, which is cost per click. And that is when an advertiser pays based on the number of users who actually click through their advertisements. As you can imagine, many users don't click through ads, so this can be an incredibly expensive way to serve advertisements or pay for advertisements. Often you'll hear CPM, which is the cost per 1,000 impressions, and that would be for every 1,000 ads that are shown, there is a cost, and how many ads are displayed determines how much that the advertiser will pay. Often advertisers will put a cap on that so that they will only serve the ads a certain number of times. And this is where analytics and capabilities like frequency capping come in, so that advertisers are able to limit how much they pay for advertisements and limit how many times an individual might see their ads to effectively serve the ads across multiple users and multiple websites. And then CPA is a cost per action, and an advertiser might determine what that action is. For example, it could be how many users end up visiting their site after having seen an ad, or downloading an app, or maybe making a purchase. And all of this is typically done with the use of cookies. But as you may be aware, the use of cookies is becoming increasingly difficult. There are inherent limitations on the use of them. Cookies can only identify a single user or a user within a single browser. So if a user used multiple browsers, for example, Firefox and Chrome, the cookies are set specific to the individual browser, and an advertiser or a website may see that user as being unique, even though it's the same device. Now, it's also possible that there are many solutions to try and overcome the limitations of cookies, but I want to call out some of the obvious limitations before getting into some of the ways that companies are able to overcome these limitations. With the increased use of browsing on mobile devices, mobile apps do not typically support the use of cookies. So that is another growing limitation on being able to do the functions that typically relied on cookies. Users are accessing more content for multiple devices and platforms, which necessitates a mechanism for tracking users across devices. And then we also see that browsers are increasingly blocking third-party cookies. You may have heard recently that Google has announced that they intend to sunset the third-party cookie functionality and are working within the industry to develop alternative solutions within the next 2 years. And I'll let Rob speak to those specific discussions a little later on this morning. Speaking of mobile apps, as I mentioned, they generally do not support cookies, but there are mechanisms that allow for advertisers and websites to be able to track users. Initially, devices provided a unique ID that was hard-coded into the device, but this became a not very privacy-friendly mechanism for advertising. So Apple in 2013 introduced and required the use of their IDFA, or the ID for advertising, to be used by advertisers. And then in 2014, Google followed suit on Android and introduced what they call the advertising ID, or the AAID. And this allowed for an identifier similar to a cookie that could be used to persistently identify a user on a device. There are also other permissions on mobile devices that users can be prompted to allow, such as use of location, access to a microphone, access to contacts or camera. There's a variety of different sensors that provide additional information to apps and advertisers and that the users can control. So the biggest control that we see on mobile platforms for in the context of advertising is the limit ad tracking mechanism. And initially, users could set limit ad tracking as a flag that would be sent to advertisers or to ad networks. And this was treated as an advertising or a behavioral advertising opt-out. It was very much on the honor system. So there have been changes as of iOS 10 on Apple devices, where if a user enables limit ad tracking, it actually zeroes out the IDFA. In essence, what that means is that the identifier is all zeros, and all users who have opted out now look to be the same to anybody receiving that ID. It prevents previously permitted frequency capping, attribution, conversion events, estimating numbers of unique users, and advertising fraud, and various debugging uses. There are mechanisms that some companies may use to work around this. However, Apple has very strict limitations, and Google as well have very strict limitations on how identifiers can be used and the contexts in which advertising can leverage certain identifiers on the device. Location data is also something that is very valuable information that can be derived from a mobile device. It can be either from directly the mobile sensors that provide GPS information, cell towers, carrier triangulation. There's also mechanisms for using Wi-Fi and Bluetooth beacons, and there are a number of emerging alternatives to derive location information from mobile devices. Increasingly, we're seeing the operating systems crack down on workarounds for deriving location information if a user has expressed a preference to opt out of the sharing of location. It is something to be aware of in developing products and services, and I recommend that any company that is leveraging location data be very much aware of how that information is being derived and ensure that there is some sort of a mechanism for users to be informed and provide their consent to the use of that information. I mentioned cross-device tracking earlier. Because cookies can only be used to identify a user within a single browser, and increasingly users are using multiple browsers or multiple devices, it's very important to have a mechanism that allows for identifying a user across multiple devices. There are a number of different models. They're typically divided as deterministic or probabilistic. In a deterministic model of identifying a user, Individuals are tracked using a stable identifier, for example, an email address when it's used across multiple devices. So for example, a user might log into their laptop and the hashed email and a cookie ID are sent to a data matching partner. If that same user logs in with the same email address on another device, that hashed email address and a mobile identifier can be sent to a data matching partner, and that hashed email address will match. And at that point, the cookie ID can be linked to the mobile ad ID, and a company would be able to determine that that is the same user as another device. What this allows for is the use of profiles that might be created on multiple devices. So if you know that somebody is an auto intender on one device, you might be able to serve them ads for a car that on another device when you see that same user. There are very complex mechanisms for doing cross-device tracking. So like I said, this is a very simplistic description of the technology to familiarize you with the concept and some of the simple ways that these can be achieved. But it is very important for companies to be able to consistently identify the same user across multiple devices, given that the vast variety of ways that individuals now access online content. Probabilistic determination methods are actually an acceptable margin of error. So for example, if you see the same user accessing your website from the same home Wi-Fi address or IP address over multiple devices, you may be able to assume that it's probably the same person. You know, they might go to the same websites, they might have the same patterns of behaviors over time, and you can make a reasonable assumption that it's probably the same user. Different companies may have a different threshold for what they consider acceptable to make a deterministic, or I'm sorry, a probabilistic link that it is the same user, but without having some sort of a definitive login event or an authoritative mechanism for a user to indicate that they are the same person across multiple devices, some leaps have to be made to assume that it is probably the same user. Another mechanism for probabilistic determination of a user would be fingerprinting or server-side recognition. And I'll just briefly talk about it here because I believe Rob is going to dive deeper into this. But the concept is that there are attributes on a device that are unique to an individual. And when you look at all of these together, they make up what would be similar to a fingerprint. So your monitor size is probably consistent. Your operating system is going to be the same. The display resolution, the fonts that you have installed, some of the plugins that are installed on your computer, whether you have certain preferences set. When you look at all of those together as a package, they make up what we would call a fingerprint and can be used over time to generally identify the same user. There is a margin of error to this, and there are mechanisms now that browsers are taking to try to prohibit this because it is very difficult to offer an opt-out to users from the use of fingerprinting. So what's on the horizon? Web and mobile platforms are increasingly building technical and privacy controls for privacy. So it is a very much a moving target to understand the perspectives of the various platforms and how they understand their users and their user expectations, and then adapt to be able to meet the goals of their clients. So you have ad networks and ad tech companies who are attempting to provide advertising services, and they must also be able to navigate the limitations and functionalities of the platforms where they're operating. The sunsetting of third-party cookies across major browsers has caused some significant discussion in the marketplace and is driving a lot of new technologies and discussions around mechanisms for providing these types of services and solutions. We also see new technologies and new access to the internet in other contexts, for example, in TVs, cars, wearables, out-of-home advertising, and facial recognition and video analysis. So there are a number of different places where advertising is emerging or ad tech is deriving information, and a lot of considerations that need to be made in those contexts. And with that, I will pause for a moment to ask if there are any questions from any of the attendees. If there's anything that I've breezed over that you'd like to understand more about, please let me know. Like I mentioned previously, there is a Q&A button at the bottom of the Zoom window that will allow you to type in your question, and we are monitoring this for to be able to either provide you responses directly within the Q&A or to have Rob or I answer any questions that you might have.
Yeah, thank you, Christy. I think this has been a great start already. We do see some of the questions coming in through the chat window and also in the Q&A. And if there's or maybe not a question, but you want to remark something that's of interest, or maybe if you want us to do a little bit more deeper dive on the topics that have been presented so far, this is a good time. We also realized that a 2-hour session is going to be pretty exhaustive. So it's also maybe we try to build in these small pauses as well for everybody to give it a little bit of a break.
Hey, Rob, it looks like we've got a couple of questions in here. This is Charlotte Crest. First question is, if you could please review again the main differences between SSPs and DSPs. So Christy, I don't know if you'd be able to take that for us, please.
Yes, the supply side platform and the demand side platform. So if you think of demand as the advertisers who need to have a place to put their ads, they are on the demand side of the equation, and the supply side is the places that are available for advertisements. So the inventory that's available, or the publisher's inventory. If you go to a website and there's a spot for an ad, that is on the supply side. And then if you are an actual advertiser looking to place your ad, then you are on the demand side of the equation. And those are basically companies that help to consolidate both the inventory and the ads, and then find an appropriate place to put them. I'm gonna let Rob get more into detail on real-time bidding, but this is where the various companies come into play to actually provide their open inventory and to provide the ads that are available to be served in, they come together at the point of the exchanges or the ad marketplaces. I hope that answers your question.
Thank you, it does. Also wondering how DSPs and SSPs interact with ad exchanges. Of course, if Rob is going to get into the details of that later, perhaps I can ask that question again once Rob has presented. But wondering if you have anything for us today.
Yeah, the linking element between the DSP and the SSP is, of course, information that can be brought to an auction. And this is the bid request. That's like the technical term for it. And in the end, it's like a super cookie. It has a lot of metadata, so data about data, such that people who want to bid for an advertisement spot on a publisher's website know what type of user is actually visiting that website at the moment. And this can be through various marketing campaigns, like Christy has already mentioned, the contextual type of advertisements. We have retargeted advertisement, but there's also the behavioral advertisements. So to answer the question on how do DSPs and SSPs interact with ad exchanges, we'll zoom into a little bit more on this missing link, the bid request.
Great, thank you, Rob. I'm assuming that we're also going to get to views regarding ad exchanges that share sensitive data during real-time bidding, particularly in light of recent complaints to data protection authorities in Europe. This may be, again, something that you're addressing during the second part of this presentation.
I'm not really going into that detail, but it is clear. I mean, I attended both workshops that were organized by the ICO, the UK Commissioner's Office, and this is where the basically the complaint that's have been put forward by Brave, which in core has a lot to do with the sensitive data points within bit requests. We will see an example of a bit request later on in the presentation to get a feeling of where this then would fit in, but it's clear that if people are targeted on sensitive categories, it's clear that that's problematic in the current discussion on changes in the ecosystem. And the UK Commissioner's Office has also provided guidance on this topic, which is available on its website.
I have another question here. I'm wondering what your thoughts are on using differential privacy in the ad tech space.
Well, this is something that's something we're going to touch on very, very briefly, because this is like a 101 on ad tech, and this specifically relates to a discussion currently also held within the W3C web advertising business group. I have different views. I've two different views on this, because on one hand, it's of course a great improvement in terms of privacy by design to basically collect and analyze data in the browser. This is a decentralized mechanism. But on the other hand, the question whether any measurement or knowledge derived from a user, even if it's de-identified when it's leaving the browser, whether that's something we are all feeling comfortable about. It's not clear from the discussion where this will lead, but of course it's a great opportunity to explore further privacy by design solutions. And I've seen multiple proposals in two subgroups that are actually being discussed at the moment. I think it's almost 20 different ones, and the differential privacy angle is one of these solutions.
Thanks so much, Rob. Also wondering about how the CCPA and GDPR solutions overlay with ad tech in general and with this process. And are companies adopting IAB's CCPA solution and the transparency consent framework solution on the GDPR side of things?
So I'll jump in and say, just to clarify, the intention of this is to provide the actual nuts and bolts fundamentals of how the online advertising ecosystem works. We are not intending to actually dive into the policy discussion today, although I'm happy to do that with folks in other contexts. I will say that there are a number of different solutions that are being developed to address various legal requirements, such as CCPA and GDPR. You'll see different websites with "do not sell my information" buttons. You'll see websites with cookie banners, or banners notifying users about the use of cookies. In real-time bidding, there are different mechanisms or differences in the actual architecture of the online bidding system that allow for the collection and transmission of permissions, which is what you see in the Transparency and Consent Framework, or the TCF. I think everybody should be aware of these different terms and aware of these initiatives, and determine how best your company can comply with whatever the specific legal requirement is, and also understanding your customers and what their desires are to best implement a solution that is both legally compliant as well as meets the expectations of your customers.
Thanks for answering that, Christy. So far, it looks like we've answered all the questions in the chat and in the Q&A function. maybe just gonna close the Q&A at this point, or if anyone has any others before Rob begins his presentation, we have some time for a bit more.
Rob, why don't you go ahead and jump into your portion, and we can keep an eye on the chat, and if anything comes up, we can address those.
Okay, I'm going to start the screen sharing from my side. So 1 second. Let me see. If all went well, the slide should be up now.
Beautiful.
Okay, yes. So we've seen that cookies, of course, are a mechanism to somehow remember when a user has visited the website, and of course this is being done in the browser, and the browser becomes a proxy for the user. So I thought maybe it's good to dive a little bit into how the browser actually works, and to simplify this, I broke it up into 6 main components. And first one is, of course, the user interface, which we see when we interact with the browser, and we're briefly going to touch on things like under the hood, like the rendering engine and the browser engine, and what the difference is between these. We'll also look very briefly on the JavaScript interpreter, which is about basically the ability to distribute programming code that is then actually being run into a browser to animate and to perform different tasks, but also, and this is where the Adtech comes in, to perform specific tasks that are relevant for making an ad smart. Networking is of course important because the browser needs to be connected to the internet in order to talk to the server and, for instance, to download the ad itself, but also to communicate back on terms of reporting on how the ad is performing, possibly to signal whether a user had clicked an ad or not. And data storage. And data storage is, of course, the element within the browser where the cookie is stored. So let me go to the next slide. The user interface is basically the front end of what you use every day. It's a normal application with standard elements like an address bar where you type the websites in with a back and a forward button. There's a toolbar, search bar, and it basically connects the browser through a backend with the operating system. And as Christy mentioned earlier, and the example of the geolocation, it's a mechanism, for instance, to know what the geolocation is, to be able to query which Wi-Fi stations are in the neighborhood. And the technical term to work through this is our application programming interfaces. The rendering engine is an important part because basically the web page consists of plain ASCII. It's like text you can read, but it's a lot of programming code, and the rendering engine makes sense of this. So it will be able to distinguish whether something is a graphic and what the position should be, but also what font to use, whether it should be bold or in italic, etc. And so it does that by parsing the code, the HTML code, and the formatting code, which is called CSS. So when the code is parsed from the left to the right, it displays it on the screen, and it's not really readable, but the image of the beer bottle on the right is represented by the code on the left. If we go to the third element, which is the rendering engine, the second element, it's good to put a little bit into context what the history of the rendering engine, an important key component of the browser, was. And it started in '83 with HTML. And in 1998, it was Netscape that actually started to release this as open source under the name of Gecko. and we still see this today in the browsers. WebKit is forked the original KHTML into Gecko as the rendering engine for Safari, and later on Blink, which is now used by Google, forked WebKit's core into a library now called Blink. And what we see later on, if we touch on the discussion on cooperation between browsers on the future of Adtech, it's important to keep these three, Gecko, WebKit, and Blink in mind. So it's, of course, Firefox and Clicks are two examples of browsers that are relying on the Gecko engine. Safari, like I just said, is running on WebKit, but Edge, which is powered by Microsoft, run on its own engine before, but they changed to Blink last year, and also Brave is running on WebKit, on Blink. And the interesting thing is that most of the engines, so most of the browsers are available for different operating systems. But it's good to see that Gecko is not present on iOS, and WebKit is not present on Windows. The browser engine links the user interface with the rendering engine. So there's like two components basically wrapped around in this image. And the Java interpreter, like I said, is an important element to translate the code of the website that the programmers have drafted into the actual images. So it's a very complex structure. I'm not going to go through all the details here, but basically there's a strict organization between the various elements. One of the ideas of JavaScript is to be able, this is like, this is to the third point, is to be able to make elements interactive. And we'll see that by an animation of the beer bottle later on as well. So the networking, like I said, is important to connect the browser to the internet. And this basically puts all the elements together. And in the data storage, we'll see that the JavaScript is the programming code that developers can use to store a cookie or to read a cookie or to store information in one of the other pieces within the browser that are available to store information in. So the storage API, that's like on the bottom of this slide, is an important API to look at, and I invite you to visit that web link if you want to read up on the details on how programmers actually work with storing that type of information. It's a little bit too much detail for 101. So let's move on to a short list of the 6 types of data storage that we see in modern browsers today. Of course, caching information is a way that if you're visiting a website and you've downloaded all the pictures that are present on a website, and if you reload or go to a next page, it does make sense to not have to load the images that are already in your browser again. So the cache is being used to temporarily store information that can be reused on other spaces within a website. An IndexedDB is a database structure that's commonly used by websites in a more structured way, to store information in a more structured way. Service worker registrations is a relatively new development. Sees to a way for basically the programmers to connect to various servers on the internet, so basically ties into the networking component of the web browser. Cookies, local storage, and session storage are 3 storage elements which we will look into a little bit more in detail later on, because the policies around these 3 mechanisms differ, which we see in one of the slides after this. So let's go back a few steps before we rush into too much detail and lose track of the story and the narrative. If we have a simple website, it's common to use an iframe within an iframe. It's like a little bit of a Russian matryoshka. You have an element within an element. And basically this is like the area, the visual area that is presented by the publisher to the advertising network, to the display networks to fill with an ad. And in this case, it's a refreshing beer bottle. So if we are going to look at how the advertisement is composed, what I actually did, and the URL of this specific ad in this campaign is visualized on the bottom right. It's it's an ad powered by the Google DoubleClick network, and it consists of one CSS file, and that's the file to basically look at the font and the font size, but also it consists of 14 different images, and there are 5 scripts, 5 JavaScripts to make this advertisement work. And the way, if you then start looking at it, it works is there's an overlay of various images. They are all put on top of each other, and then the JavaScript is used to basically shift its position and to enlarge a little bit of each element so that you get the illusion of a video. You can also change the text, which is shown on top. And this is a popular way of basically sending and basically filling the ad space that's available. And this specific ad is designed by an Amsterdam-based company called Bennebase, and it's powered like the DoubleClick for publishers and the DoubleClick ad exchange. Another example here, it's a little bit more complex animation powered by Weborama in an iframe. It actually consists of 36 different images, and they have 2 scripts around it to animate the ad, but also to make the ad smart in terms of measurement. And in the URL, you also see 2 interesting variables that are sent to the ad network. One is that this ad was shown on the desktop. So it's important when you start rendering an ad that you know how much space do I actually have to display my ad. Does it have to be a small one on a mobile phone? Does it need to be rectangular in a horizontal way or vertically? There are like different popular positions to position an ad, and most of that information is conveyed through the APIs in the bid request to make sure everybody knows, okay, we have this specific ad space which can be filled. We also have this user that's actually visiting the website at the moment. He's looking at this context. And please, if you want to show them an ad, let's bid on this in real time. This was powered by Weborama. They use machine learning to optimize the campaigns and the delivery, but also with lemon pie. And they claim that the intelligent dynamic creative platform that they have actually empowers the marketeers and turns advertising into personalized storytelling. So in terms of retargeting or behavioral targeting, where in the first instance you want to show an ad and reach visitors that already have been on the publisher's website before, or when it's about behavioral, when you want to market to people in a specific audience segment, they use the machine intelligence for that type of campaigns. So if you look at behind the scenes, what I'm trying to convey is that Adtech and the whole process of loading a website and seeing the ad is being made possible by a large number of companies that specialize in specific parts in the value chain. So what we see here is because I've shown you a Dutch ad for a beer bottle, a quick glance at how the programmatic ecosystem looks like in the Netherlands. There's already quite a number of organizations that all specialize in specific elements. And if we then go look further, This is a slide you've possibly seen before. So apologies for the buggy Zoom connection. I think it has to do with the internet connection here, which is not very stable from my home at the moment. So one way of simplifying the MarTech 5000 is by grouping it, like Christy said, in sell side and buy side. And if you go to the next slide, please. There are a number of identifiers that are being used, and Christy mentioned the hash of the email address, and she also mentions the device identifier on Android, but also on iPhone. This is an overview of different types of identifiers that are being used to basically try to have a deterministic way of linking a device or to a user. And some of these you'll see have the word hashed in front of it. That's a mathematical calculation to basically change an ID into a little bit of a longer number. And it's a measure to mitigate the risk of that number, or in this case, the Google identifier or the email number, to make sure that that's not basically getting into the wrong hands, because it does contain some sensitivity about the original user. So it's a way of pseudonymizing the original information or de-identify the information. Next slide, please. So here we have an animated slide with, on the left and on the right, two examples of pieces of information within a bid request, which basically connects the consumer to the advertiser site. And the category IAB the 927 is falling into the category of behavioral advertising. It's an indication of an audience segment, and it's related to basically targeting on consumer behavior. A second example is geolocation on this site, and there you see things like the lat long, which is a way of indicating the positioning on the Earth, but also just like more on a more aggregated level, which is like city level or region or country level. Here we see two different identifiers. The first one is the IP address, which is relatively stable. For instance, the IP address here on my internet connection, that's not very helpful today, but that's like a static address, which is if the cookie syncing doesn't work. So if you have a user that's visiting your website and you can not connect it to a database with previously stored cookies, then a fallback scenario could be to have the IP address or the IP address in combination with the user agent, which is just above the IP address, as two types of data to recreate a relatively stable identifier over time. So a unique user ID, you'll see both on the left and left top and on the bottom right, but also a buyer ID, which has to do with the campaign, basically the marketing company that's buying the ad. And we see some additional information on the bottom, which is an indicator that's often used to show whether you may have seen a specific advertisement before, you may have interacted with this ad, and a buying intent is then a strong indication that you may actually be on the market for the purchase of a product or not. Next slide, please. So I promised to go a little bit deeper into the intricacies of fingerprinting. And there is a website which I used to see what are the fingerprinting capabilities on the data that my browser is basically displaying or sending out when I'm visiting the web. And that website is called miunique.org/FP of fingerprinting. And what it basically says is that, well, that if we compare the information that we can derive from your browser over the last, and compare that to the information we derived from other browsers over the last 90 days, the question is, are you unique? Well, you are unique enough. I'm unique enough to be tracked. And important elements that are used here are the fact that I'm running it on Windows, I'm using Firefox, it has a specific version, but also I'm located in Rotterdam. It's the time zone, but also language. It's set to English. And that combination, specifically already the last one, the language aspect, turns out to be a strong piece of information to have you stand out or to let others single you out within a large group as a unique individual. And next slide, please. Other examples of fingerprinting information that can be derived are the way information is displayed through the rendering engine. And the canvas, this is the top bullet, shows an example on the right that 20%, oh, sorry, I have to enlarge that window a little bit. There we go. So I'm so unique that I'm with, well, 2 out of 100 people have the same probabilistic information in there. And the list of fonts actually is so unique on my browser that basically the fonts I have, if you would make a mathematical calculation and do a hash on all the fonts listed on my computer, there are not a lot of people who have the same list. So maybe I just installed one specific font that makes me stand out of the crowd. The screen size is also a little bit different than what others have. And then we see things like the last one, audio. That's a very interesting one. The specific way my laptop is basically making the sounds has a very specific pattern, and that is because it's created with hardware components that, even if they are from the same series, in the manufacturing process, they're still slightly different. And you can use those physical characteristics of the components of your machine, and if they are being put to use, you can measure these differences, and this is what's being exploited by fingerprinting scripts. And this has been studied in detail by Gunnar Saska, and by Eubank, and also Stephen Engelhardt and Arvind Narayan in their famous paper, The Web Never Forgets, Persistent Tracking Mechanisms in the Wild. And I highly recommend downloading that paper. Next slide, please. So what we've seen here is all based on what we know, and it's all theoretical. But if we want to make sense of that MarTech slide with 5,000 different companies, we may go a step further and look at an empirical model for real-time bidding. And one way of doing that is to observe the information that's being transmitted and received by the browser through the network component. And if you do that, you can actually look at what different types of servers are actually being communicated with. And what I visualized here is a way of basically telling that story and also storing that information in a database. It's called a graph database. You'll see in the middle on the left, label A with URI. That's actually the website that I'm currently visiting. And the URI -1, this is on top, just like the most top left bullet. That's the website which I visited before I came to the website which I'm on now. And in the same way, you can also say, okay, what's going to be the next website I'm going to visit? That's the one on the bottom, the URI +1. Well, let's focus on the website I'm actually visiting now. So the one that contains the beer bottle. So what it does in order to have that bottle to be displayed and to be able to download all these 6 pictures that together compile this slowly moving beer bottle, I have to go to a third party and request these images. But maybe that third party doesn't have the actual images, which says, okay, I don't have them, but I know on which server they're actually are. So I'm going to redirect you to the real server where they are. So in this way, you get a little bit of a chain of different server calls and different third parties. And so to say, it gives you a way to visualize the way the ad is rendered. So instead of the advertisers tracking you, it's a way to flip it the other way and say, okay, are we able to actually track the different types of companies that are making these ads possible? So next slide, please. So if we apply this empirical model to our advertisement, I made a visualization of the different types of interactions that are actually happening. So what we see in the middle is the website www.nu.nl, where this image, where the ad was displayed. And you see spiraling out various calls to different third parties. And the interesting one on the bottom right is that this webpage does contain some social networking elements, but we also see that, for instance, there's some audience measurement going on. There's, like I said, a little bit on the right, in the middle, it says scorecard research, for example, and a little bit more on above on the green and the purple, we see Google Analytics, and we see another tag. Well, to sum up, there are many elements on the page, and some of them are like really functional to visualize the publisher's content. And that's why on the left, you see like a big branch going all the way to the left, where all the static images are being stored to compile the website of the publisher, but also there are all other elements that specifically see to this ad. And to be sure, the URL that we've seen before, that's the URL. If I load only that URL within that iframe, then this is the resulting graph picture that is being displayed to us. Next slide, please. So if you do this on a more larger scale, for instance, what I did here is I started visiting all the national and regional newspapers within Germany, in this case. And if you store all the visited pages on one node, it becomes possible to start comparing the various third parties that are at present on all these different websites. And the data set I built was a set of almost 1,000 websites, like I said, on national and regional newspapers all throughout Europe, so all 27 countries. And if you then start applying network science algorithms to the graphs, it's possible to start isolating the different real-time bidding networks. And the bidding network that we see here in the red, that's the visualization of the Rubicon network. And if we move our attention to the more summary box on the right, you also see a big cloud in yellow, which is basically representing the Google real-time bidding network. The thesis where this is all explained with also other examples is downloadable on the SSRN website, and the URL is on the bottom. Next slide, please. So storing cookies in the browser is something we zoomed into a little bit, and it becomes important to understand that there are differences between the browsers. What we see here is that the protection in terms of blocking third-party components differs quite a bit. So for Chrome, there's not a default blocking mechanism. Firefox has the so-called enhanced tracking protection mechanism, which is visualized by a small shield just before the URL when you type it in the address bar. And Safari has the intelligent tracking protection, which is an algorithmic way of trying to differentiate between requests to third parties and determining whether those are related to tracking by third parties or not. So in the end, privacy note, go back one slide, please. Yes. It's important to keep in mind that, of course, privacy by design only works for a majority of people when it's enabled by default. And that's the case now for both Safari and for Firefox. And they do this on either a blacklist. For Firefox, it's the disconnect list. So they don't do that themselves, it's outsourced to that company. And there's an algorithmic approach, like I said before, which resembles a little bit the graph approach, which I used to measure the impact of the various third parties while visiting different websites. Next slide, please. So cookies in the first party context. The first party is the website that you're visiting. You see that for these cookies, there are no restrictions in Chrome and Firefox, but there are some policies on if you store or set a cookie in a browser. For Safari, there's an expiration automatically set to 7 days. It doesn't exist there forever. And for cookies, with document.cookie expiration set to 24 hours on pages with the URL declaration, which is sometimes you see a page that ends with .html, and then you get a question mark, and then you get a lot of text behind it. Those are called query parameters. Basically, Safari filters this and says, okay, we do have a higher risk for these type of URL requests, and they may be relate to the tracking and to advertising. And this is why you have a stricter policy on cookies that are set through this mechanism. And so you see, it's important to also think in the first party context, what happens when I close a tab? What happens when I close the browser? And is it really closing and clearing the cookie store? Is it really cleaning up the cookies what I did? So what I do myself is I sometimes hit the Control-Shift-Delete key to purposely clear the browser and to remove all the cookies that have been stored. The problem though is that it will also delete your login cookies. And if you want to read your newspaper, you will have to log in again if you have a subscription. So it's a little bit of a more crude way, but it becomes important, specifically on mobile. A lot of people do not really close their browser. You might just swipe it away such that it looks like it's running in the background. But if you really want to clear the cookie state, you have to go to File and then say Quit. And then it depends on your default settings whether the browser will really be cleared or not. Next slide, please. So other browser storages in first-party context do not have restrictions. This is like local storage. We saw the IndexedDB. There was this list of 6 different types of cookie storages. With Safari, there's a restriction for 7 days if you had meaningful interaction with elements on the site. And this can mean a click or a tap or text input, but it's more than just hovering around. So this is also a policy that's in place, and you see that Safari is actually a little bit more sensitive on giving memory to your browser visits, your website visits. Next slide, please. So cookies in a third-party context. And this is where it becomes interesting, because this is where the discussion is all about. At the moment, actually quite recently, Safari changed their policies to be even more strict. And they are now as strict for the Access API as Firefox is. As Firefox is restricted for known trackers. And Safari has restricted all access except for the storage access API for cookies in a third-party context. So those are cookies set and read by third parties that are not the same as the URL of the page that you're visiting at the moment. And this ties into the announcement of Google that they will join Firefox and Safari in blocking all third-party cookies. But they have a sunset period of at least 2 years. And this is why the Adtech, so a lot of the MarTech companies were actually very worried because they still heavily rely on the cookie, the tracking cookie, to be able to operate their advertising businesses. Next slide, please. So what happens with the other browser storages? Chrome still does not have any restrictions there. For local storage and IndexedDB and session storage, there are small differences. And I'm not going to go into too much detail on this side, but it's clear that there is a distinction between Chrome and the other browsers. Next slide, please. So the 3 observations are, if you are a publisher or if you're a DPA and you want to perform a cookie audit or a cookie sweep like the Irish DPC did a report on this week, it does matter which browser you're using. And if you are trying to explain your methodology, I think it's also important to show what the configuration was. Did you make any changes or did you use the default settings? And it certainly makes a lot of difference what browser you're using. Because in the last bullet, we see that it sometimes matters on what policies the browser have introduced are actually in place. And there's a somewhat related discussion on cookies. It's a security field, whether those policies are actually in place or not. So Google is at the moment actually rolling back, a temporary rolling back of a measure of default browser enforcements of the so-called same site cookie policy in light of the COVID-19 outbreak. And this policy sees to, and this is part of the 3rd bullet, and then the middle sub-bullet, a cookie must match the sites from which the cookie is accessed. So this is the URL that you are actually going to type in, and whether that cookie is accessed or not. So otherwise the cookie must be blocked. So this is the policy rule, even though the sites and cookies are of the same party. So if you are a bank or have a large website that operates on different subdomains like a.fpf.org or b.fpf.org, those both websites A and B are part of the same company, but the browser doesn't know and will differentiate between the two. So it's a development that's related to the browser storage discussion on basically putting a sunset on the possibility to store cookies in a website versus how do we deal with cookies from other sites. I just wanted to put it out, but like it's a good time to do a short break. I saw this in the chat passing by. Browser persistency is very complicated, to say the least. I fully agree with that. So Christy, shall we have like a short break or shall we continue? What would be a good way to go forward?
Well, we have a half hour left on the time for this. Do you have that? I don't think you have that much more left, do you?
Okay, I saw something on the chat that somebody was asking for a quick pause before the next section. What we could do is maybe let's take 2 questions before we move on.
Okay. Charlotte, do we have any questions in the queue?
Sure, we do. We have one question relating to why Chrome is where it stands as far as restricting tracking, user tracking, relative to browsers such as Firefox and Safari.
I think I'm going to address this in the next slide. So I'm going to hold that question for a second. Yes, we're going to return to it in the end of the presentation.
Okay, and we have another question that says, can you explain why there is same-site cookie labeling?
Yes, this is a result of a discussion that is actually around this RFC, which is the slide which is still on, in the IETF, the Internet Engineering Task Force. They design protocols, and the cookie protocol, of course, has to include elements in terms of privacy risks, how to mitigate those. And part of the discussion has been security attacks like cross-site forgery requests and other ways to circumvent, for instance, how you log into a website, for instance, a shopping cart or a bank. And you can imagine that you want to make sure that because the web is designed not with memory in mind, that the way cookies were designed in the 1994, 95 to remember whether you bought an item and put it in the shopping cart is something completely different than the risks we face today with cybersecurity risks and, for instance, identity fraud. So things need to be done to make the use of cookies as a functional mechanism more secure, and one of the aspects is the same side discussion that happened throughout that standardization process in the IETF, and that led to stricter policy rules on how browsers must deal with cookies that do not display this same site attribute, or because there are different ways you can set the attribute, how browsers are going to react in terms of being a little bit more relaxed on the interpretation, or maybe be very strict on the interpretation. But the thing is, if you're going to go use cookies, the idea is that you have to disclose upfront and make available to the browser where the cookie is coming from and within which context that cookie is supposed to be used. And if the browser cannot determine that purpose, the default policy should be to block that cookie.
Thank you, Rob. Looks like we have 2 more questions and a raised hand from the attendees. Did you want to take that couple-minute break before getting to those, or do you want to go ahead and answer those now?
I would be happy to go ahead. I mean, people can use the 2 or 3 minutes to take the pause. So please, let's go through the 2 questions that are there, and then see how we can bring Carlos in, or maybe he can type his question in as well.
Okay, great. So the next question is, with regard to Safari's algorithmic protections, is it true for both the desktop and the mobile versions of Safari?
To my knowledge, I think it is, but I'm not totally familiar whether it is the same implementation. I've seen that for Firefox, the tracking protection is in place both on mobile and on desktop, and I know that the disconnect list is the same for both, and I do expect it's the same as well for Safari, but we do have to keep in mind that those are 2 different browser versions, and they may not be at the same level of compliance all the time. So my generic answer is yes, but the more nuanced answer would be you have to really go into the browser version to be sure that they're all at the same page.
Great. And then lastly, why do privacy policies distinguish between session and persistent cookies?
I think this is a response to basically the attention of the regulators, but also the way the laws are drafted in the various jurisdictions. I know there are very specific information requirements here in Europe, in terms of, well, basically disclosing information on cookies. So I think that would be my simple answer to that question. Yes.
I would also add to that there's also the likelihood that a session cookie that is only going to be used for a very short window of time might be used for maintaining more robust information than you may want to have your browser retain for a longer period of time. So a privacy policy might describe that they may use session cookies for more robust purposes, whereas a persistent cookie might just be to recognize a user or retain a specific preference that they can then notice on a next visit.
I do agree with that, but I also want to put out that that the term session is being misused to some extent as well, because if you look at the length of a session of a mobile browser session, it actually is so long that it's almost the same as when you are really rebooting your phone after a big update, and that doesn't happen a lot. That happens maybe a few times a year, and there's just a minority of people who really go into their browser settings and clear cookie state by hand. So that it really, the session is terminated, and that the session cookies do not persist anymore. And so far, I do agree, a session has been framed many times or often as, okay, this is functional, it's to provide the user experiences during that session. But I just want to point out that that session sometimes can be much longer than we think it's going to be. So if I inspect a cookie website, I always look into what type of cookies are set into the session storage. And a lot of times, third-party tracking cookies are being mirrored in the first-party session storage as well. This gives an indication that Adtech is using this session storage as well to make sure there's some type of persistency that can be helpful in connecting a user to already known information on the server side.
It's an excellent point. Thank you.
Okay. Did Carlos maybe also add a question to the queue, or shall we move on to our next slide? Charlotte?
He did not ask a question in the queue. It looks like his hand is raised, and I believe either a host or a co-host might be able to unmute him or to have a chat with him about his question. Yeah. But maybe we could have him do that while you continue.
Yeah, maybe we can ask Carlos to type the question and see if we can take that question after the coming. I think I have like 5 slides left. So. Okay. Next slide, please. So why does browser persistency matter for our real-time bidding? Of course, there are many reasons, but the main 3 reasons that stand out for me are cookies and other tracking mechanisms are still important for impression tracking and reporting, which is giving an answer to the question whether an ad is seen or viewed and whether a user has clicked or interacted with an advertisement. It's also because of a behavioral targeting. If a JavaScript tag on a website A is firing the same cookie on as the JavaScript on website B, then C can track this user. And the third is the remarketing aspect, which is the cookie syncing with information that has previously been collected, but maybe under different cookie IDs. And Christy gave the example of the hashed email address of being a connecting identifier. Often a third-party cookie with other information can be used to provide this. And other terms for remarketing are like interest groups or user lists, remarketing lists, or custom audiences, behavioral market segments. The real-time bidding request, which we've seen before in the presentation, did contain this IAB category, That's an example of such a remarketing category. And this relates to one of the first slides Christy showed on the difference between contextual advertising, retargeted advertising, and behavioral advertising. So next slide, please. So the end of third-party cookies relates to basically Google also saying, we want to change the landscape. Privacy by default is important. What if we are going to deal with a future in Adtech where we block all third parties? That's like the baseline to start the discussion with. And if the discussion on how to move to that near future is actually happening in 3 places, at least in 3 places at the moment. And one of it is the community group, the privacy community group within the World Wide Web Consortium. There's a second group, it's called the Improving Web Advertising Business Group, and the IAB launched a project called the REARC. Next slide, please. So the difference between these 3 is that the community group is chartered with the purpose of incubating privacy-focused web features, but also application programming interfaces to improve user privacy on the web through enhanced browser behavior. That's like a generic way of saying, okay, we want to change the way people experience tracking, like retargeting and behavioral tracking. And the discussion is led by the browser teams of Microsoft, Mozilla, and Apple. Whereas in the business group, Google is actually very, very vocal. But some of the proposals, sorry for the typo here, have implementation interest from Gecko, Blink, and WebKit, the 3 engines that we basically looked at the beginning of this presentation, and proposals that have enough consensus within this community group may spin out to like a standards group, like it's called in the W3C a working group. And this can either be a new working group being established or an already existing W3C working group like the Web Adtech working group. But of course, there are other groups as well where you can start a standardization process, and the working group community is another example. So next slide, please. So if we look at the discussions that are actually happening within that privacy community group, this is actually an animated slide, so you can hit the next. You'll see that some of these will have the interest of one, and some of them have multiple browsers, vendors that say, okay, we would like to implement these browser features. And this is where you see that, for instance, the second one, the analytics mode, doesn't have any interest yet. That means it's a very relatively new idea that's being discussed within that group, but it's mature enough to start testing and implementing. And this is how you see that in various stages of maturity, these ideas are being discussed between the different browser vendors. If they agree on, okay, this use case is important to deal with, then you can dive into the details of, okay, of what are the requirements and how are we going to implement this within our own browser, such that we can actually start testing it and see whether the problem that had been raised through the issue is actually solved or not. Next slide, please. So in contrast, the group, the Improving Web Advertising Business Group, has a similar mission, but it's not totally the same. It's to identify areas where standards and changes in the web itself can improve the ecosystem and experience for users, and to oversee liaison with existing work groups and to create new work groups as needed. Well, this is a very diplomatic mission or charter, and this is also because it's chaired by the W3C itself. It's a neutral group to talk about new ideas for the future of Adtech, and it's not a new group. It already exists since the end of 2017, but it's a group that Google chose to collect feedback on the use cases for their privacy sandbox when they announced that they were going to stop allowing third-party cookies in 2 years' time. And the way Google phrased it was that with continued iteration and feedback, privacy-preserving and open standard mechanisms like the privacy sandbox can sustain a healthy ad-supported web in a way that will render third-party cookies obsolete. Next slide, please. So there are at the moment 1, 2, 3, 4, 9 different topics being discussed. And last week we had a group call, and I raised the question on which of these ideas is actually mature enough in comparison to the others, and the answer was that the conversion measurement API is an idea that has been discussed most and has come to a point that there's more and more consensus of the problem that they are trying to solve, and the API, basically the functionality that will be exposed for others to use in the browser through JavaScript to be able to continue to perform conversion measurement even after third parties have been made impossible. So it's an API for impression tracking and reporting. Like I said on the previous slides, it's whether the ad is viewed and whether a user clicked on the ad. So the impression tracking is one category. And if we go back to that categorization of 3, there are 2 issues tied to targeting and remarketing that are actually look for, okay, if we want to keep the targeting marketing campaigns possible, is there like a privacy friendly way to do this? And the initial idea was launched as an acronym, the FLOC, the Federated Learning of Cohorts, which includes, and this relates to one of the questions in the chat earlier, in solutions around differential privacy. And the remarketing idea was coined as Pigeon first, but is now called Turtle Dove, and that's an acronym of 2 uncorrelated requests, then locally executed decisions on victory. It's a long acronym, but in the end, it boils down to a solution after third-party cookies are going to be enforced by the Google browser by default, so there are no third-party cookies anymore, and still having APIs for programmers to do some type of privacy by design remarketing, which is, like we said before, a way to market to audience segments. Next slide, please. And the last project, and this is also the last slide, is about Project ReArc. It's a response by the Interactive Advertising Bureau, which are of course not a browser vendor, but do have a big interest in okay, what type of business models will still be possible after third-party cookies, and are we actually going to be able to influence that future or not? So I know the IAB is also taking part of the discussions in both working groups, but they are also very active in their own working groups. So they established various working groups, and I'll just point you, before I go to the next bullets, but the first one, their mission is, with the loss of third-party cookies and potentially the mobile ad IDs as well, the default future state of digital media will be 100% anonymous, non-addressable to third-party vendors that support advertising-funded media and services today. Okay, that would not be a very good outcome for the 5,000, or at least a lot of the 5,000 MarTech companies. So the addressability working group, with a focus on standards for privacy-centric use of identifiers, accountability working group, with a focus on a framework for practice for addressability, and also the business working group, with a focus on bringing together businesses, policy leaders. I like the 3 core working groups. And then there's the ReArc task force through IB Tech Lab, where all the protocols are being designed, like the real-time bidding request we've shown is actually one of the standards that came out of the IAB Tech Lab. It has a focus on bringing together the publisher, the buyer, and the platform community, so the supply side and the demand side, to specialized trade groups, consumer advocacy, and NGOs and other bodies. So that's an important third group where a lot of discussion is happening in, and of course these three groups talk to each other as well. There are people who sit in the privacy community group that also sit in the web advertising business community group, and some of them also are part of Tech Lab. So, but in terms of ideas, it's interesting to see in which groups are these discussions being discussed, and how much buy-in is there by the different browser vendors. That's something what I keep an eye on, and I also hope to contribute to these discussions. This was actually my last slide. Maybe you can put the next slide up, and then we can start looking at the queue.
Thanks, Rob. That was really fascinating, very informative. Do we have any questions in the queue? And I would also ask anybody who's on the call, if they have any questions, feel free to click the Q&A button at the bottom of the Zoom webinar window, and you can type your questions there.
Thanks, Christy and Rob. We have one question so far. What is the assessment of the cookie preference tools in managing this environment?
I think if I understand the question correctly, I just want to ask Mark whether he means the default cookie preferences within the browsers, or maybe something else. Okay. So it's about the current tools show buckets. Yeah, there are all the major browsers do have the developer tools in place, and there you can see the various basically stores in which information can be stored. And they do have different buckets. I don't think that the third-party bucket will disappear, but at least not for some time, because it does make sense to be able to keep track if that store is still there. I'm not sure whether that store will be removed from the from the browser altogether. But having said that, the discussion is about the privacy sandbox, so we may well see a replacement or a relabeling of that of such a bucket, and then be called privacy bucket to see what type of information is in there. In the end, the whole idea on the decentralized design of privacy sandbox is to have a large storage that can contain a lot of behavioral data, which can be analyzed such that with, for instance, differential privacy, whatever can be learned from that behavior may contribute to a better retargeted ad or a more privacy-friendly behavioral marketing campaign. So I do think, I'm not sure whether the third-party cookie bucket will remain, but I'm almost sure that we'll see one or more additional buckets, because we do need local storage in the browser, which is larger than the cookie store, which, if you look at it from a design point of view, it was designed in the 90s, and you cannot contain or store a lot of information there. It's very limited. This is one of the reasons why, with the HTML5 development, the IndexedDB and other storages have been created to allow for much more information storage. But of course, these storages are still too limited to do machine learning within the browser. So I do expect there's going to be a lot more local storage. And of course, it makes sense to make that available and transparent to the developers as well.
Wonderful. Thank you for the clarification, Rob. Looks like we don't have any more questions in the queue. However, perhaps either you or Christy would be able to provide just some general, maybe good books or a reading list on this topic if some of our listeners want to read up on what we've been talking about today.
Well, I would say that there is no one book currently that I would recommend as a go-to for this. Online advertising is an enormous market. It encompasses the technology, the marketing aspects, the advertising components, and it is just, I think, too broad to have one book that covers it, but and the speed at which it changes, I think it'd be out of date before it was even published. However, I would say that we have a number of different resources that we've drawn from in pulling together these presentations, and those were notated throughout. I'll also say that the FPF website has an entire section dedicated to advertising, online advertising, Adtech and location. We also have a monthly working group that is available to FPF supporters, and it meets on the first Thursday of every month. And I would encourage companies that are interested or involved in this space to join that working group, or at least to be part of it from the perspective of receiving the announcements, readings, and updated information that we provide. We're also recording this webinar, so this will be available likely on our website shortly after we finish. By shortly, I mean probably within a week or so. So give us a little bit of time to get everything polished and posted. We may also do future live sessions well, not in person at the moment, but we will do likely live sessions again in the future. So keep an eye out for invitations if you have folks who are interested in joining who were not able to participate today and maybe don't want to watch the webinar. We would encourage them to join these sessions as well.
I'd like to add that we do have recordings of previous sessions that we did. Of course, the narrative changes through time, but they are on our website under the Digital Data Flows Masterclasses. And I highly recommend looking at these recorded sessions as well.
Yes, I'll also say I'll volunteer Rob and I as well. Our email addresses are on the screen, and I'm confident that I know I am willing to answer any questions anybody has offline, and I am certain that Rob would as well. So feel free to reach out
same here.
if you if you didn't get a chance to ask your question today, or if you come up with questions later as you're mulling this all over, we're happy to follow up with you directly and have conversations on any questions you might have.
Yeah, I do agree, and I do realize it was a lot of information to take in. We tried to structure this a little bit, but in order to understand the current discussion on the future of Adtech, it is important to lay some kind of foundation on how browsers work and how ads work. And as you've seen, advertising, online advertising is a very complex system that involves many different companies, but also involves a lot of different data flows. We're not talking about just one type of real-time bidding system. As we've seen, there are multiple real-time bidding systems. And of course, some companies sign up as a partner to one or more of the dominant real-time bidding platforms. But there's also between these platforms a lot of information that needs to be exchanged. And in our attempt to hide some of that complexity, we try to simplify well, the way browsers work and how that relates to the information that's passed on between all these actors in the ecosystem, and basically how that relates to privacy questions like how is it possible to recognize a user? We heard about profiles, but where is that information stored? And how is that information in the end connected to future visits from a user on a website? So these are like very complicated questions, and happy to do more follow-up discussions on that if you reach out through the email. That's very happy to do. And before we close off, because we have like 1 minute left, I do want to apologize for the technical difficulties that we experienced today. We were going to debrief and see if we can do some kind of lesson learned to prevent that in the near future. But it is busy times. A lot of people are working from home, also in my apartment building. And this may actually be a cause of the fluctuations in quality of the internet provided. Maybe you can close off, Christy.
Yeah, I think that's a great way to wrap it all up. I would thank everybody for joining today and look forward to continuing to work with you again in the future. And that concludes our webinar for today.